Structured query language, foreign keys, maintaining relationships between tables. In this video, we're going to explore how foreign keys in SQL help maintain relationships between different tables in a database. What is a foreign key? A foreign key is a column, or group of columns, in a table that refers to the primary key in another table. It creates relationships between tables, enforces referential integrity, prevents invalid data entry, and enables efficient queries across tables. For example, in a database with a customers table and an orders table, the orders table might have a customer ID column that is a foreign key referencing the customer ID, which is the primary key in the customers table. This ensures that every order is associated with a valid customer. Foreign key syntax. To create a table with a foreign key, you can use the following SQL syntax. Create table orders, open parenthesis, order ID integer primary key, customer ID integer, order date, foreign key, open parenthesis, customer ID, close parenthesis, references, customers, open parenthesis, customer ID, close parenthesis, semicolon. To add a foreign key to an existing table, you can use the following SQL syntax. Alter table orders, add foreign key, open parenthesis, customer ID, close parenthesis, references, customers, open parenthesis, customer ID, close parenthesis, semicolon. Foreign key actions and constraints. When defining a foreign key, you can also specify what should happen when a referenced row in the parent table is deleted or updated. These are known as onDelete and onUpdate actions. For the onDelete action, this structured query language code shows how to create a table called orders with a foreign key that references the customer's table and specifies that when a customer is deleted, the corresponding orders should also be deleted. Common options for onDelete include CASCADE, which deletes related rows, set NULL, which sets the foreign key to null, restrict, which prevents the deletion, and no action, which is similar to restrict. For the onUpdate action, this structured query language code shows how to create a table called orders with a foreign key that references the customer's table and specifies that when a customer is updated, the corresponding orders should also be updated. Common options for onUpdate include CASCADE, which updates related rows, set NULL, which sets the foreign key to null, restrict, which prevents the update, and no action, which is the default behavior. Here's an example of a database schema that uses foreign keys to define relationships between tables. The customers table stores customer information, such as customer ID, name, email, and phone number. The customer ID is the primary key. The orders table stores order information, such as order ID, customer ID, order date, total amount, and status. The order ID is the primary key, and the customer ID is a foreign key referencing the customers table. The order items table stores information about the items in each order, such as item ID, order ID, product ID, and quantity. The item ID is the primary key, and the order ID and product ID are foreign keys referencing the orders and products tables, respectively. The products table stores product information, such as product ID, name, price, and description. The product ID is the primary key. The relationship labels define whether the table has one-to-many or many-to-one relationships. Querying related tables with joins. To query data from related tables, you can use structured query language joins. This code shows how to use an inner join to retrieve orders with customer information where the total amount exceeds $100. It selects the order ID, customer name, order date, and total amount from the orders and customers tables, joining them on the customer ID column. The results table contains the order ID, customer name, order date, and total amount for each order that meets the specified criteria. Multi-table join example. This code shows how to select customer name, product name, quantity, price, and subtotal from the customers, orders, order items, and products table. It joins customer ID from the customer table with the order table. It joins the order ID in the order table with the order items table. It joins the product ID in the order items table with the product table. Benefits and best practices of using foreign keys. Foreign keys offer several benefits, including maintaining data integrity across related tables, preventing orphaned records, simplifying database design and documentation through standardized relationships, enabling cascading updates and deletes, and improving query performance through optimized joins. To make the most of foreign keys, follow these best practices. Always define foreign keys to link related tables. Use consistent data types between primary and foreign keys. Create indexes on foreign key columns for query performance. Choose appropriate on update and on delete actions based on business requirements. Consider the performance impact of foreign key constraints, especially in high-volume transaction systems, and implement proper indexing to mitigate any potential issues. Key takeaways: foreign keys. In summary, foreign keys create relationships between tables, enforcing data integrity. Foreign key columns reference primary key columns in another table. On delete and on update actions control behavior when reference data changes. Joins use foreign key relationships to combine data from multiple tables. Foreign keys prevent orphaned records and maintain database consistency. By using foreign keys effectively, you can design robust and reliable databases that ensure data integrity and facilitate efficient data retrieval. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.